Hi everyone, and welcome to our first video lesson of the year on adding and subtracting polynomials. Here's some vocabulary for you here. Polynomials are expressions with two or more terms, and terms can either be variable or numeric. So we've seen variable terms before, such as maybe like 2x or 5y squared. Those are variable terms. And of course we know numeric terms are just numbers. 2 and 5 would be numeric terms. Okay, so if you need to get that vocabulary down, pause here. So let's talk about adding polynomials. Well, when we're adding polynomials, it's really easy. We're just adding like terms. So get rid of any parentheses that are there. The parentheses are there to group. We don't need them anymore. Identify like terms, and then we're going to simplify by combining like terms. Pause here if you need to get those steps down. Okay, so let's look at some examples here. So my first example is to add the quantity of 3x squared plus 5x minus 1 and add that to the quantity of 4x squared minus 2x. So first thing I'm going to do is I'm going to rewrite this without parentheses. 3x squared plus 5x minus 1 plus 4x squared minus 2x. And now all we need to do is identify and combine our like terms. So lots of people do different things when they identify their like terms. I like to do different shapes. So my x squared terms I might put in a box. And my regular x terms I might do in a circle. Notice how I'm also circling the sign that comes right before it. And then I've got this little -1 all by itself. So there's nothing we need to do with that. So we'll combine our like terms. So in our box, we have 3x squared and 4x squared, and that makes 7x squared. In our purple circles, which rhymes, we have a plus 5x and a minus 2x. If we combine that, that's 5 minus 2, which is 3. And then we have our minus 1 all by itself. And there's our answer. Okay, so I want you to try number 2 on your own, and we'll come back and check on it in class. Now, what if we're subtracting polynomials? Well, I want you to think, how do we subtract integers? Well, we subtract by adding the opposite. So suppose we wanted to evaluate the expression 4 minus the quantity of 3 minus 8. Well, we could think back to our order of operations. We know that we can just do 4 minus, and in parentheses, 3 minus 8 is -5. Okay, we remember from the past couple of years that if we subtract a negative, that's the same thing as adding something. Remember, if you take away something negative, you get more happy, you get more positive, right? That's one way to remember it. So this is really 4 plus 5, which we know is 9. Well, I also want you to consider this. Let's say I rewrote the expression like this. This original expression, 4 minus the quantity of 3 minus 8. Let's say I wrote this, 4 minus 3 plus 8. So notice what I did. This became minus 3. This became plus 8. Okay, because really what you want to think about here is I'm subtracting a positive 3 and I'm subtracting a -8. Well, let's work this out. 4 minus 3 we know is 1, plus 8 is 9. So we got the same answer here. And we're going to use that same strategy when we go to subtract polynomials. So what I want you to do is consider this expression here. The quantity of 7b squared minus 2b plus 13 minus the quantity of 4b squared minus 5b minus 6. So let's read this together. As with addition problems, we want to get rid of the parentheses. However, the subtraction sign in the front of the second group of parentheses will change the sign of every term inside the second group of parentheses. So what is this expression after the parentheses have been removed? Okay, so we'll write the first one. The first one doesn't really change. 7b squared minus 2b plus 13. Well, here's where things get different. So if you think about what we did up here, we had our original expression, which was 4 minus the quantity of 3 minus 8. Well, what I could do is rewrite this as 4 plus negative 3, which is the same thing as this minus 3 over here, plus 8. Okay, and we can work that out. It's the same thing as this right here. 4 plus negative 3 is 1, plus 8 gives us 9. So what I did is I changed that minus sign to a plus, and then I changed the sign of everything after it. So we'll do that here. We'll change this minus sign to a plus, and then change the sign of everything after it. So that positive 4b becomes a negative 4b squared. That negative 5b becomes a positive 5b. And that negative 6 becomes a plus 6. Okay, so now we can simplify. So I'll box in my b squared terms. I'm going to circle my b terms, making sure I circle the sign in front of it as well. And then I'll underline my number terms. So now I know exactly what to combine together. So I've got this 7b squared and a minus 4b squared. That gives me 3b squared. I've got this minus 2b and this plus 5b. And that gives me plus 3b. And then finally we have this plus 13 and a plus 6, which makes 19. So there you go. You have simplified two polynomials by subtracting them. I'd like to see what you can come up with on this next example here. So work on that and we'll go over it in class. Lastly, I want to talk about how this connects to geometry. So sometimes when we're working with lengths, we have quantities that are unknown. And so let's look at that. So I have here this example. Suppose Stacy wishes to place 2 pictures on a wall in the hallway. The lengths of the 2 pictures are 12 inches and 20 inches respectively. Stacy also wants the pictures to be the same distance from the ends of the wall and the same distance from each other. Stacy has not figured out this distance yet. Write an expression which represents the length of the wall in terms of these measurements. Okay, so sometimes when we have problems like this, a good strategy to do is to draw a sketch. So I'm going to draw this wall. So here's this hallway wall. And we've got 2 pictures on it. We've got this 12-inch picture, and we've got this 20-inch picture. Actually, I'll go ahead and label those. So that's might be what it looks like. Well, some things to consider is that Stacy wants the pictures to be the same distance from the ends of the wall and the same distance from each other. So think same distance. Here, this space right here, this space here, and this space here are going to be the same. Well, think about this. We don't know what that distance is, and when we don't know something in math, we usually give it a variable. So we'll call this distance x, and since they're all x, we'll call them all x. So look at what we have. If we wanted to write an expression that represents the length of that wall, well, I have x plus 12 plus x plus 20 plus x, taking all of these measurements all the way across the wall. And we'll go ahead and combine like terms. Box in our x terms. Of course, making sure we get the sign in the front. And we'll circle our number terms. And of course, boxing and circling, you can use other techniques as well. Underlining works. You can use different shapes. You can highlight in different colors. Whatever works for you. Okay, so we'll add up together our terms. We have 3x's, so that's 3x. And then a 12 and a 20. Well, that makes 32. So even though it's a lengthy word problem, we can definitely break that down and use a model or a picture to help us solve that. Okay, so this last one has to do with perimeter. And of course, we want to remember from early geometry that perimeter is the distance around something. Okay, so a farmer farms a piece of land that is roughly rectangular in shape. He decides to cut out a square piece of land right here. We don't know the size, it's an unknown size, and build a baseball stadium. The diagram below shows that model. We're going to write an expression to represent the length of each side, and we're going to write an expression for the perimeter of the land that will be farmed. I want you to work this one out on your own as well. See if you can come up with an expression for each side, and we can label those. We can call this side 1, side 2, side 3, side 4, side 5, and side 6. Notice that 4 of the sides are given to you already. We already know that this side is 500, this one's 300, this one's x, and this one's also x. So really what you're trying to do is figure out what is the length of side 3 and side 6. And then combining all the sides together to come up with a simplified expression. See what you can come up with. And finally, make sure you summarize and reflect. Tell me what you learned. What things are you still struggling with so that we can go over those in class.